Hi there, future teacher. Welcome to your FTCE Professional Education Test Prep lesson, proudly presented by TeacherPreps.com. In this video, we're covering Competency 1, Instructional Design and Planning, which makes up 18% of your exam, roughly 14 questions. This is the largest competency on the entire FTCE 083, so mastering this content is critical for passing. We'll cover assessment methods, Bloom's taxonomy, Webb's depth of knowledge, learning theories, backward design, culturally responsive planning, and the RTI and MTSS intervention frameworks. Before we dive in, we put together a free study guide workbook that goes along with this video. It has all the key terms, comparison tables, practice questions, and space for your own notes. Grab your free copy from the link in the description. This video is part of our complete FTCE 083 Professional Education Test Prep at TeacherPreps.com, where we offer study guides for every competency, full-length timed practice tests, vocabulary exercises, and more. Our program is self-paced and free to start, so when you're ready, visit us at TeacherPreps.com. All right, now let's get into the content. Grab your notebook, because we've got a lot of ground to cover. Let's go. Competency 1 is all about how teachers design and plan instruction. It covers 10 skills, and here's the big picture. Effective teachers don't just walk into a classroom and wing it. They start by assessing what students already know. They set clear learning objectives aligned to standards. They choose strategies based on research-backed learning theories. They plan instruction that meets diverse learners where they are, and they use data to intervene when students fall behind. That's the arc of this entire competency. Assess, plan, teach, differentiate, and intervene. Let's break it down skill by skill. Skill 1.1 is about choosing the right assessment at the right time. Assessment isn't something that only happens at the end of a unit. Effective teachers assess before instruction, during instruction, and after instruction, and each type of assessment serves a different purpose. Let's walk through the 4 main types you need to know. First, diagnostic assessment. A diagnostic assessment is given before instruction begins. Its purpose is to identify what students already know and what misconceptions they have so the teacher can plan instruction that meets them where they are. Think of it like a doctor running tests before prescribing treatment. Examples include pre-tests, KWL charts where students list what they know, what they want to learn, and later what they learned, interest inventories, and skills checklists. Here's how it works in practice. A third-grade teacher is about to start a fractions unit. She gives a quick pre-test and discovers that most students understand halves and fourths, but nearly half the class thinks that 1/3 is smaller than 1/4 because 3 is less than 4. That misconception about fraction size tells her exactly where to focus her teaching. Without the diagnostic assessment, she might have spent 2 days on content they already knew and skipped the concept they actually needed. Second, formative assessment. Formative assessment happens during instruction. It's ongoing, real-time monitoring of student understanding that the teacher uses to adjust teaching on the spot. The key characteristic of formative assessment is that it's low stakes. It's not graded in a traditional sense. It's a check for understanding. Examples include exit tickets, where students write a quick response to a question before leaving class. Think pair share, where students think individually, discuss with a partner, then share with the whole group. Observation checklists, where the teacher watches and records student behaviors. Whiteboard responses, where students hold up answers simultaneously. And questioning techniques, where the teacher uses strategic questions to probe understanding. Here's the critical part. Formative assessment only works if the teacher actually uses the data to change instruction. If a teacher gives an exit ticket and half the class gets it wrong, but she moves on to the next lesson anyway, then the assessment didn't serve its formative purpose. The whole point is to identify gaps in real time and address them immediately. Third, summative assessment. A summative assessment is given after instruction to measure what students learned. It evaluates whether students have achieved the learning objectives. Summative assessments are typically graded and carry more weight. Examples include unit tests, final exams, end-of-course projects, standardized state assessments, and portfolios that show cumulative work. The key difference between formative and summative. Formative assessment is assessment for learning, used to improve instruction, while summative assessment is assessment of learning, used to evaluate mastery. Think of it this way. Formative is like a coach giving feedback during practice. Summative is the game on Friday night. Fourth, benchmark assessment, also called interim assessment. Benchmark assessments are administered periodically, typically 3 times a year, at the beginning, middle, and end. Their purpose is to track student progress toward meeting grade-level standards and to predict how students might perform on end-of-year state assessments. They sit between formative and summative in scope, broader than a single exit ticket but narrower than a final exam. School districts often use benchmark assessments to make data-driven decisions about curriculum and resource allocation. For your exam, remember this. Diagnostic tells you where students start, formative monitors progress during instruction, benchmark tracks growth across marking periods, and summative measures what was learned at the end. Now let's make sure you can match the right assessment to the right purpose, because that's exactly what your exam will test. If a teacher wants to check understanding mid-lesson, she uses formative assessment, like a quick thumbs up, thumbs down, or whiteboard response. If she wants to measure mastery at the end of a unit, she uses summative assessment. If she wants to identify starting points before a new unit, she uses diagnostic assessment. And if she wants to track growth over the school year, she uses benchmark assessment. Also know the difference between formal and informal assessment. Formal assessments are standardized with consistent procedures, like state tests or published diagnostic instruments. Informal assessments are teacher-created and flexible, like observations, conferences, and student self-assessments. Both have value. Formal assessments give comparable data across students, while informal assessments give richer, contextual information. Skill 1.2 is about fostering higher-order thinking. Let's start with the framework you absolutely must know, Bloom's taxonomy. Bloom's taxonomy is a hierarchy of 6 cognitive levels, from the simplest to the most complex. Level 1 is remember. This is basic recall. The student retrieves facts, definitions, or lists from memory. A question at this level might be, what year did the Civil War begin? Level 2 is understand. The student explains ideas or concepts in their own words. For example, explain the difference between weather and climate. Level 3 is apply. The student uses information in a new situation. For example, use the area formula to calculate the area of a garden. Level 4 is analyze. The student breaks information into parts and examines relationships. For example, compare and contrast the causes of World War I and World War II. Level 5 is evaluate. The student makes judgments based on criteria. For example, which solution to pollution would be most effective and why? And level 6 is create. The student generates something new. For example, design a plan to reduce energy consumption in your school. The bottom 3 levels, remember, understand, and apply, are considered lower-order thinking. The top 3, analyze, evaluate, and create, are higher-order thinking. On your exam, questions will test whether you can identify which level of Bloom's a task targets, and whether you can design activities at the higher levels. Now let's learn Webb's depth of knowledge, or DOK. While Bloom's classifies the type of thinking, Webb's DOK classifies the complexity of thinking required. There are 4 levels. DOK 1 is recall and reproduction. Students recall a fact, definition, or simple procedure. Example, what is the capital of Florida? DOK 2 is skill and concept. Students must use mental processing beyond recall. They classify, compare, organize, or estimate. Example, sort these animals into vertebrates and invertebrates. DOK 3 is strategic thinking. Students must reason, plan, and use evidence to support conclusions. There are multiple valid approaches, and students must justify their thinking. Example, using data from the experiment. Explain why plant A grew faster than plant B and cite specific evidence. DOK 4 is extended thinking. Students conduct investigations or apply learning across multiple contexts over an extended period of time. Example, design and carry out a research project on water quality in your community, analyze the data, and propose solutions. Here's the key difference between Bloom's and Webb's for your exam. Bloom's asks what type of thinking is the student doing. Webb's asks how deep and complex is the demand of the task. A task can be at the create level of Bloom's, but only DOK 2 if the creation is simple and formulaic. For rigorous instruction, you want tasks at DOK 3 and 4. Now let's look at specific instructional strategies that promote higher-order thinking. Socratic questioning involves the teacher asking a series of probing questions that lead students to discover answers through their own reasoning. Instead of telling students the answer, the teacher guides them with questions like, what evidence supports that? What would happen if the opposite were true? Problem-based learning, or PBL, presents students with a real-world problem that has no single right answer. Students must research, collaborate, and propose solutions. For example, a class might investigate how to reduce food waste in the school cafeteria. Inquiry-based instruction puts students in the role of investigators. They form questions, gather data, and draw conclusions. In science, this might look like students designing their own experiment rather than following step-by-step lab instructions. Project-based learning is similar to problem-based learning but results in a tangible product. Students might create a documentary, build a model, or design a website. Debate requires students to evaluate evidence, consider multiple perspectives, and construct arguments. It's inherently at the evaluate and analyze levels. The key for your exam: when a question asks about promoting critical thinking, the correct answer will involve students doing the thinking, not the teacher delivering information. Skill 1.3 is about designing learning experiences where students actively demonstrate skills and competencies. There's a fundamental difference between passive learning and active learning. Passive learning is when students receive information, like listening to a lecture or watching a video. Active learning is when students do something with the information. They discuss, create, solve problems, experiment, or demonstrate understanding. Research consistently shows that active learning produces deeper understanding and better retention than passive approaches. One of the most powerful frameworks for active learning is the gradual release of responsibility model. It follows 4 phases. Phase 1, I do. The teacher models the skill or process explicitly. Students observe and listen. Phase 2, we do. The teacher and students work through examples together. This is guided practice with the teacher providing support. Phase 3, you do together. Students practice in pairs or small groups while the teacher circulates and provides feedback. Phase 4, you do alone. Students demonstrate the skill independently. This is where the teacher assesses whether the student has truly learned. The power of this model is that it gradually shifts the cognitive work from the teacher to the student. A common mistake is jumping from I do straight to you do alone, skipping the guided and collaborative practice that builds confidence. Cooperative learning structures are essential tools for active demonstration of knowledge. Let's cover the ones you need to know. Jigsaw. Each student becomes an expert on one piece of the content and then teaches it to their group. Every student must demonstrate understanding because their group depends on them. Numbered heads together. The teacher poses a question, students discuss in groups. Then the teacher calls a number, and the student with that number must answer for the group. This keeps every student accountable. Reciprocal teaching. Students take turns leading discussion using 4 strategies: predicting, questioning, clarifying, and summarizing. Think, pair, share. Students think individually, discuss with a partner, then share with the whole class. This ensures everyone processes the information, not just the students who raise their hands. Performance-based assessment tasks are another key concept. These are tasks where students demonstrate learning through action, like giving a presentation, conducting an experiment, or creating a product that shows what they've learned. Authentic learning connects these tasks to real-world applications, tasks that mirror how knowledge is actually used outside of school. Skill 1.4 is about selecting the right instructional resources based on measurable objectives and student needs. Let's start with measurable objectives. A well-written objective tells you exactly what the student will do, under what conditions, and to what standard. The ABCD format helps you write them. A is for audience. Who is doing the learning? Usually your students. B is for behavior. What observable action will the student perform? This must be a measurable verb. C is for condition. Under what circumstances will the student perform? D is for degree. To what level of proficiency? Here's an example. Students will identify, meaning that's the behavior, the 3 branches of government. Using their textbook and class notes, that's the condition. With 80% accuracy, that's the degree. Notice the verb is identify, not understand. Understand is not measurable because you can't observe understanding. but you can observe a student identifying, comparing, constructing, or analyzing. Always use observable, measurable verbs from Bloom's taxonomy when writing your objectives. Once you have a clear objective, you select resources that match the cognitive level of that objective. A recall objective might need a textbook or reference chart. An analysis objective might need primary sources, data sets, or case studies. A create objective might need art supplies, technology tools, or design materials. Beyond matching the cognitive level, you also differentiate resources for varying performance levels. Below-grade level readers might need modified texts with simpler vocabulary, graphic organizers, or visual supports. On-level students use the core curriculum materials. Advanced learners might need extension materials, primary sources, or independent research opportunities. English language learners need visual supports, bilingual resources, and materials with context clues. When evaluating any instructional material, ask yourself, is it accurate? Is it aligned to the standard? Is it at the appropriate reading level? Does it represent diverse perspectives? Is it engaging, not just informative? And is it free from bias? These evaluation criteria come up frequently on your exam. Skill 1.5 is about learning theories, and this is one of the heaviest topics on the entire FTCE 083 exam. There are 4 major learning theory families you need to know. Let's start with behaviorism. Behaviorism says that learning is a change in observable behavior caused by external stimuli. The key idea is that what happens outside the learner drives the learning. The major theorists are Pavlov, Skinner, Watson, and Thorndike. Pavlov demonstrated classical conditioning with his famous dog experiment. He paired a neutral stimulus, a bell, with food. After repeated pairings, the dog salivated just hearing the bell. The dog learned to associate the bell with food. In the classroom, classical conditioning explains why students might feel anxious when they see a test paper. They've associated tests with stress. Skinner developed operant conditioning, which is about the consequences that follow behavior. Positive reinforcement adds something desirable to increase a behavior. For example, giving a student a sticker for completing homework. Negative reinforcement removes something undesirable to increase a behavior. For example, excusing a student from a chore when they earn a good grade. Punishment adds something undesirable or removes something desirable to decrease a behavior. In the classroom, behaviorism shows up as token economies, behavior charts, praise systems, direct instruction, drill and practice activities, and immediate feedback on assignments. The second theory family is cognitivism. Cognitivism says that learning is an internal mental process involving how the brain encodes, stores, and retrieves information. Unlike behaviorism, cognitivism looks inside the mind. Let's cover the key theorists. Piaget developed the theory of cognitive development with 4 stages. The sensoromotor stage is from birth to age 2. Infants learn through their senses and physical actions. The preoperational stage is from ages 2 to 7. Children develop language and symbolic thinking, but struggle with logic and seeing other perspectives. The concrete operational stage is from ages 7 to 11. Children can think logically about concrete objects, but struggle with abstract concepts. The formal operational stage begins around age 11. Adolescents can think abstractly, hypothetically, and systematically. This matters enormously for instructional planning. If you're teaching 8-year-olds, they're in the concrete operational stage. They need hands-on manipulatives and concrete examples, not abstract symbols and formulas. Ausubel contributed the concept of advanced organizers, which are tools presented before a lesson to activate prior knowledge and give students a framework for organizing new information. The information processing model describes learning as a 3-stage system. Sensory memory captures input for a fraction of a second. Working memory holds and processes a limited amount of information at a time, and long-term memory stores information permanently. Classroom applications of cognitivism include graphic organizers, chunking information into manageable pieces, mnemonic devices, connecting new content to prior knowledge, and scaffolding complex tasks into smaller steps. The third theory family is constructivism, and this is the most heavily tested theory on the FTCE 083. Constructivism says that learners actively build their own understanding through experience and social interaction. Knowledge is not transmitted from teacher to student like pouring water into a cup. Instead, Students construct meaning by connecting new experiences to what they already know. Vygotsky is the central figure here. He developed the concept of the zone of proximal development, or ZPD. The ZPD is the range between what a learner can do independently and what they can do with guidance from a more knowledgeable person. Tasks below the ZPD are too easy. The student gains nothing. Tasks above the ZPD are too hard. The student gets frustrated. Tasks within the ZPD are the sweet spot, challenging enough to promote growth but achievable with the right support. That support is called scaffolding. Scaffolding is temporary, structured assistance that is gradually removed as the learner gains competence. Think of literal scaffolding on a building. It supports the structure while it's being built, and it comes down once the building can stand on its own. In the classroom, scaffolding looks like sentence starters for writing, graphic organizers for reading, worked examples in math, or guided questions during discussion. Vygotsky also emphasized social constructivism, the idea that learning happens through dialogue, collaboration, and negotiation of meaning with others. Classroom applications include inquiry-based learning, cooperative learning, project-based learning, discovery learning, hands-on exploration, and discussion-based instruction.